Okay, so let's talk about characteristic impedance, which is one of the first gid nga electrical characteristics of transmission lines. So characteristic impedance, as you can see, there's a definition. It's affected by the length of your transmission line. So the longer it goes, yung TL, oops, the longer it goes, there will be resistances. Oops. Let's put it up here. There will be resistances due to your conductor. Also, there will be inductances due to high frequencies. As we will show later, there are also capacitances that we call parasitic capacitance. Parasitic capacitances, it's unavoidable. So as long as you have two electrical or electronic components next to each other, there will always be a certain capacitance nga matabo. That is why ang aton nga C diri nga symbol is in between your two transmission lines. Aside from that, of course, ang imo conductors, they will be coated by an insulator, or let's call that dielectric from here on. Okay? Since they will be coated by dielectrics, there will be shunt leakage resistance or leakage resistance of the dielectric, as you can see here. That's this guy. Okay? And all in all, because of that, ang aton nga TL, it will have its own characteristic impedance, which is also called your surge impedance. Okay? So erase this. Now, for low frequencies, ang aton nga equation will be this. By the way, the symbol ZO is the symbol for characteristic impedance. For higher frequencies, amo ni siya aton nga equation. The original equation actually came from this. Is ZO is equal to R plus J omega L over G plus J omega C. Now, let's look sa ato nga past. So, XL or your inductive reactance, equation niya is 2 pi FL. Atong capacitive reactance is 1 over 2 pi FC. Ang aton nga F or frequency, affected gid ni siya kaayo sa aton nga, or gina-affect niya gid ang aton nga reactances, no? So, for XL, the higher your frequency, the higher your reactance. As for XC, the higher the frequency, the lower your reactance, capacitive reactance. I have compared earlier, what if ang aton nga capacitance is 1 millifarad? Ang aton nga inductance it's 1 millihenry. So, compare ta, what if ang isa 50 Hz so pala tayon ta nga frequency, ang isa naman niya is 500 MHz. So as you can see, 50 Hz is the frequency sa aton nga kuryente. Like sa house. Yeah, you know that. Well, 500 MHz is kumbaga the start sa microwave communications. So nakatesting ko kag nakita naton ang difference nila, no. For 50 Hz, it's 3.18 ohms, capacitive reactance. Meanwhile, for 500 megahertz, it's 318.31 nano ohms. As for your inductive reactance, it's 0.314 ohms and it's 3.14 mega ohms kung 500 megahertz ang imo frequency. There is a significant increase and decrease in value, which just shows na if it's a lower frequency, you are good with RNG. Actually, ang imo nga resistivity or resistance and ang imo nga conductance will be much larger than the reactances nga napakita naton diri subong. Yep, again, your resistance and your conductance will be much larger than the reactances that we have tried to solve. So that is why R and G are the ones considered for low frequencies. Meanwhile, those values will be negligible for higher frequencies. Kay as you can see, ang aton nga reactance magically weird ang ilang mga prefixes. Yeah? Okay. So just remember that. Anyways, for electronics, since we are in communications, we will always deal with higher frequencies. So, for us, let's see. For us, ang mag-initiya ang ating gamiton nga equation square root of L over C. For parallel, another equation for that would be impedance of a short circuit and impedance of an open circuit, which is also rarely used, but just remember that. But ang pinaka-important gid nga equation for parallel wire lines, so this includes your twin lead and your UTPs, your twisted pair ng mga wires. And for coaxial cables, you have this value. You will be given the dielectric constant, okay, with the symbol. Yeah, if it's air, it's 1. If it's polyethylene, it's 2.3. If it's Teflon, it's 2.1. If it's polystyrene, kita mo lang isa sa unit tak nando ka styro blah, that's 2.5. So these are the ones that you may want to memorize. Air 1. Sometimes hindi ka makibot. Sometimes there will be sources giving you air is equal to 1.02. Yung dielectric constant. It's 1.02, but our source, Tomasi, just uses 1. So that's good. Polyethylene naman na siya ang duka plastic na duka strands. Bala nga makita niyo sa coax kis 2.3. It's quite the same as Teflon though. Okay, so remember these equations. Yep. So let's erase. Okay. One of the important gid ng mga mediums sa broadcasting is your free space. Now, what is the impedance of free space? We don't know the inductance and the capacitance of that, but we do know the permittivity and permeability of free space. Permittivity will deal with the electric field. Therefore, kabalo kita nga ina siya, isulatan na siya sa aton nga C, diri o capacitance. That's 8.85 times 10 to the negative 12 farads per meter. Now, ang ating permeability of free space deals with magnetic fields, and therefore that goes to your inductance. Up here, that's 4 pi times 10 to the negative 7 henries per meter. Let's root that, grab our calculators. This will give us the exact value. Pero, ang constant na ginatag sa atin per me is 377 ohms. So, kumbaga, di na siya naghalin. Okay. So, what we have was, or is, 376.82 ohms, which is ang ginhalinan sa constant na 377 ohms as given by other sources. Yep. Okay. So, let's get rid of this. Okay. Common coaxial cables. So you have here the RGs, which stand for radio guide. Radio guide. Okay. Common radio guide impedances would be 50 and 75. 50 and 75. Okay. Compared to your twin leads, which are around 200 to 300 ohms. So 200, 250, 300 ohms. Okay? As you can observe, ang aton nga mga frequencies for coaxial cable, they are around the megahertz nga range. Kag amugid ni siya per me ang aton nga hilabtan. Yep. Okay. Attenuation nila. So you have attenuations that are measured in decibels per 100 feet or decibels per 100 meters. It's part of the specs and you should see that sa printed sa coating sa aton nga coax cables, no? Okay. Oops. Before that, yeah, let's talk about this. Correct. Okay. So, para sa aton nga comparison sang coax kag sang twin leads. So, twin leads originally were created, no, not twin leads, more like twisted pairs kali. Twisted pairs. Twisted pairs were invented by, you think it's new because it's used in computers, but actually it was Alexander Graham Bell who invented that for his telephone. Yeah. So of course it started with your UTP, unshielded twisted pair. It's because there is the so-called destructive interference if ang imo nga mga copper or imo nga conductor nakalinya sila nga kumbaga tupungay lang balahaw or sa imo nga twin lead. Pero compare mo bala sa twisted pair, ang twin lead ya do separated gid sila by a good distance. Ang aton being nga twisted pair do ka kitid gid bala sila duha. So what happens in destructive interference is if you have two conductors, the negative side may transmit this and your negative man akong positive side. And your negative can transmit this. And as you may know, ini siya, mayara sang or gamay nas bala, gamay nas ang amplitudes sa aton nga signal. Yep. So, gasubtract ang amplitude sa aton nga signal and they are about the same amplitudes, then babay ng imo nga signal eh. At the end of the line, you will receive a flat signal. Almost wala na. So, what they did is to twist it, and with that, ang ila kumbaga nga mga sine waves wala naga-align. And therefore, gakaibanan ang interference between them. Gakaibanan ang imo nga destructive interference. Also, it improves the crosstalk and noise leakage. Noise leakage. Ang noise leakage kakaibanan man. But it was good until they went higher, no? So, as they went higher sa ilang frequency, kay gagutok na ang lower frequencies naton, kag damo na sa technology ga ka-invent, they got to experience the so-called skin effect, which I think na-mention ko sa inyo several times before. Ang batasan sa aton nga waves in higher frequencies, they want to get out of your conductor. So, from the center of the conductor, it just really wants to get out. Okay. And to conserve that energy, ginputos nila ang aton nga twisted pairs with a metal shield. That's where your shielded twisted pair was invented. And then the higher they went, especially sa na-invent na, or especially sa nakita nila nga, oh, hindi na kayo go ang VHF channels, they have to go to UHF. Kabalo ka mo ni So, very high frequencies were the lower channels sang una sa ABS-CBN. There's 4, GMA you have 7, I think. And then eventually, with UHF or ultra-high frequencies, nakita niyo sa ABS-CBN, there was, I think, channel 30. Kag same man sa GMA, they also made their own channel 40. I'm not sure anymore because wala na ABS-CBN. So sad. They had to create the coaxial cable. So, what's the difference between them? Coaxial cable has your inner conductor, and then your inner conductor is then coated with another dielectric, and then outside sina may pagit sa outer shield, which is the braids. Ang sayap gigatawag sina is braid. Kaya na braid magina siya. And then there's another outer insulator, which should be made of the same dielectric. So again, you have polyethylene, polystyrene, you have Teflon, and then sometimes you have air. And then after that, you have another plastic covering. So this makes sure nga skin effect is lessened. Yeah, skin effect is lessened. Aside from that, the difference between them, if you've read their modules, is that coaxial cable is an unbalanced line. Yep. And yeah, however, coaxial cables hindi Japon na maintain pag-prevent sa skin effect as we went higher sa aton na frequency range. So we had to create the waveguide, microwave waveguides, which we will talk about later man sa aton nga course. Okay? So, erasing this. Oops. Yeah, we're good. So, what are we going to talk about now? Let's try to solve some problems. Simple lang ang problems with characteristic impedance. So, for example, let's start with this one. Determine the characteristic impedance for an air-filled concentric transmission line with P over D ratio of 4. Now, when we say concentric transmission line, since it's concentric, for sure that's a coax cable. Wala naman sang iban pa. Yeah, charot. So, ang ato nga conductor nga ari day, and then you have your braids outside, and that makes the whole thing concentric. Yep. Okay. So, ang equation sa aton nga coax cables is ZO equal to 138 over square root of your dielectric constant log D over D. Okay. Or the outer diameter over the inner diameter. Oh, check ta lang para cute. Oops. Yeah, it is. It is. What was that? Yeah, there you go. Okay, so very simple. To get the characteristic impedance, just 138 over square root of. Now, it says it's air-filled. So, let's just write 1. Yep. Log of 4. And this should give us 83 ohms. Okay. So, the example coaxial cable given these instances gives us 83 ohms na characteristic impedance. Okay. What if striktohon ta siya kag testingan tagid ang specific nga dielectric constant sang air 1.02. Kung ibutang na sa inyong mga kalkyo, you should get 82.27 ohms. Yeah. Anyways, it's quite simple para sa equation sa aton na characteristic impedance. There's another one. So, a Teflon dielectric RG316 has an inner conductor diameter of 0.54 millimeters. What is the shield conductor diameter if its characteristic impedance is 50 ohms? So this one, nangita lang ko ni spec sa internet, and let's see if it actually matches. Yep. So, let's write down ang aton nga dielectric is Teflon, so ang iyasin ang constant should be 2.1. Ang inner conductor diameter niya, so that's the small d, that's 0.54 millimeters. And the characteristic impedance ZO is 50 ohms. So, set up your equation, that's 50 equals 138 over square root of 2.1 log the big D, which we need, over 0.54. This makes it 50 over 138 over square root of 2.1 equals log D for 0.54, no? And yeah, using your calculators, bala naman kamo sila siguro. You will find that the outer diameter is 1.83 millimeters. Yeah. Okay. So, for now, characteristic impedance is quite chill. But, this is the first one kag actually gina-apply, ginasampaw-sampaw pag ini siya sa iban, pag nga ang mga characteristics ng TLs naton. So, yep, that's it for characteristic impedance. See you on the other video. Yay!